You are listening to the Wi-Fi Ninjas podcast, where we talk about wireless technology. Here are your hosts, Mac Daring and Matt Starling.
Hello everyone, and welcome to our latest Wi-Fi Ninjas podcast. I am your co-host, Matt Starling, and joined today with my co-host, Mac Daring. How are you, Mac?
Totally fine. Thank you very much. How is it going for you?
Very good, thank you. Thank you for asking.
What is so good that is going for you, man? It's like I've heard that you've had some developments today of things that are nice that I'm jealous of.
Oh, you mean picking up my new car?
Yeah, man. Like everyone is paying you too much. New car. I've seen your video of your new car with all the gadgets in it. It makes me feel like I want to have a new car now as well, man. It's like, how many screens do you have there?
Quite a few, actually. I think there's at least two, one in the dash above the steering wheel and then one in the main console display. But it's nice to finally have a car now to have as many gadgets as a tech nerd like me would like to have.
Yeah, this is totally crazy. Like you have like 13-inch screen or something crazy like that. It looks like a little bit like Tesla actually inside. So very, very gadgety and have all the newest, latest and greatest thing. So level 2 or level 1 autonomous drive, can you change lines automatically?
I haven't tested it out. I've literally just drove it back from the dealership. I've barely even played around with it. I know that the screen's a touch screen because I've been playing around with that. I know it's got the lane assist. I don't know if it would automatically move me. I think if I went to move out of a lane, it would kind of try and correct me. But
yeah, okay. So come over, give me the keys, and I will show you how it works.
Yeah, okay, no worries. You can upgrade your Skoda.
Yeah, I wish that was true. I can't afford anything now. It's like I have different plans. But anyway, we are going to talk today about Wi-Fi assessment, validation survey, troubleshooting survey, you name it. It has multiple different names. But this is a very important topic that what we are going to talk about today. It's like we are doing it on a daily basis, pretty much. And
yeah, I have to say it's probably one of our most common surveys that we do, isn't it?
Exactly. So honestly, like I do it every week, sometimes every day, sometimes every week, but every week is like at least every week. So we tend to go, not always us in person, but we tend to review the captured data of engineers that go on site to capture the data for us, or we go ourselves. In most cases, we go ourselves, and then we review that, and then we come up with a summary, like what we've noticed on site, what was good, what was bad, what are the recommendations that are important for the client to follow after the engagement with us. So let's just start maybe with what it is. So Wi-Fi assessment, validation survey, troubleshooting survey. Who is it for, Matt? Who would benefit from this kind of engagement?
So typically we will get asked by when we're doing a survey for Netidic, the customer will be having some form of issues, they'll be getting complaints, people can't connect, people will be getting dropouts, there'll be black holes of coverage apparently, devices will be struggling to roam, so they kind of want, just come in and do a survey, just do a survey. You know, surveys are very broadly used term when it comes down to Wi-Fi surveys and terminology, but it's like doing the assessment is pretty much one of the most common ones we do. Even when we're doing our predictive on-site APNS surveys, we're still collecting data that we end up assessing the network for. So yeah, typically it's usually a customer that's having some form of issues, or maybe they've had the network in for a little while and they're looking to possibly upgrade and they just want to know, how are my current access points positions, are they okay? Is my configuration okay?
Yeah.
You can't come and tell me.
And also very frequently they come over to us just for documentation purposes. So change in management, change in team. Some things they were just in engineers' heads, never documented. So they want to understand how many APs they have and where they are, even without having any issues. But in most cases, it is based on the issues that the client have. Brownfield site and issues troubleshooting followed by recommendations. Also, very frequently, we sell together RF assessment, so validation survey, together with something that we call configuration assessment. So it's not like a survey type of thing that you go on site and and check everything with your Sidekick or any other devices, or scan the network or do a packet capture. You don't do that as a part of the configuration assessment normally, but they go head in head or hand in hand or whatever you call it in English.
Hand in hand, yes, hand in hand.
See? Okay. So normally RF assessment validation survey is all about the physical side of things, radio frequencies. So you go on site, you do your full survey with your favorite surveying tool, and you capture the spectrum data and probably Wi-Fi scan and this kind of stuff. This will give you an indication about how the network is configured, because you will see in the network scan what amendments are enabled, what are the data rates and what are the SSIDs, how many of them, what is the PHY, so like what is the standard that is being used. It's not the standard, it's a PHY. But is it like old network or new network? Or you can see that all without even taking a look at the controllers. So wireless RF assessment validation surveys pretty much vendor agnostic. So if you know how Wi-Fi works, you can work with anything. You go on site, and it can be Cisco, can be Aruba, can be Mist, can be anything. You will be able to tell the client what is wrong just by peeking at network scan and results of your Ekahau or any other tool site survey. And then configuration assessment that we tend to do, like I would say in more than 50% of the validation surveys that I do, configuration assessment is a part of that engagement as well. How about you, Matt? Do you see that the same trend in your team?
Yeah, all the time. I mean, even recently I did a predictive survey for a customer in London where I went and done a design. I did a design offsite, and then went up and did my on-site element to validate my design, and I done them a very nice documentation and advised them where they needed to install the access points, how they need to install the access points, how they should configure the Wi-Fi network, but they did the implementation themselves. And then, funnily enough, at the beginning of this week, once they actually had installed it, the users started to use it, and there was complaints that the Wi-Fi wasn't working properly. And I was like, there is no way.
Sign, man.
I was like, there is no way. If you've installed the access points how I recommended, how many, and configured them how they should be working, the Wi-Fi will work amazing. So I asked the customer, it was a Meraki installation, some MR56s. And I just said, look, can you add me to your dashboard so I can have a look at your configuration? Because in the documentation that we provided to them, I was very clear how I set out for them to configure the network. So yeah, they gave me access, and I had a look around their configuration, and I could see within about 2 minutes exactly why they was having roaming problems on some of their Surface devices, and users were complaining.
What was it?
So the first thing I looked at was the configuration, because it was a particular SSID that they said that it was having issues with in their devices. So this was their corporate SSID in their Surface laptops, and they were saying that they were not roaming very well. So they were hanging on to an access point, and if they were trying to be on a video call or voice call or trying to do anything, and they were moving around the office, there was a really poor experience. So I had a look at the SSID to see how it's configured. And the first thing I noticed is that they were using Radius.1x ETLS. So I then wanted to see if they had any of the fast roaming amendments enabled, but I couldn't see the option to enable 11R on the SSID because they had used a layer 3 roaming configuration rather than bridge mode on Meraki, which if you have layer 3 configured for the SSID, you do not get the option to configure 11R, so it's just off by default. So every time the Surface laptops were going to roam between access point to access point, they were having to do a full .1x radius authentication, so taking a seriously long time in Wi-Fi to roam. And then I looked at the rest of the configuration. So I did recommend that the corporate SID was to be 5 gigahertz only, which they had done. But what I did recommend was static 20 megahertz wide channels. But I had a look at the RF profiles for the London site that it was, and they had left it to Meraki to make the decision on what channel width to use.
How did it work out?
Well, I think they had about 30 access points spread over a few floors, and there was a whole bunch of mixture between 20s, 40s and 80s, so they're going to be having a lot of primary secondary overlapping BSS, so we know that's a big no-no in Wi-Fi and can be causing a lot of issues. That's why
the mechanism is enabled, right? Like the protection mechanism. So I believe you will be using request to send, clear to send as well, making sure that the communication is still maintained on the control level. So
yeah, and the other thing as well, they hadn't disabled the low data rates like I had recommended, but So yeah, I had a little poke around their configuration. I sent them an email just to say, hey, look, could you try these configuration tips that I sent over? And that was towards the beginning of the week. They tried it, and then they said all the issues have gone away and they're all working great now. So very happy to hear that, because I knew, it was my Wi-Fi design, and if they followed my guidance and configuration, of course it's going to work spotlessly. So
of course. Why would you ever doubt it, man?
Yeah, exactly. So sometimes, like, no matter what type of survey you do, you always end up doing some form of assessment. So that was a different one, because I just done the predictive and the survey design stuff. We didn't do the implementation like we usually would, but the customer implemented it how they interpreted it to be, and unfortunately it wasn't working out how they wanted it to be. So then they came back.
Okay, so the take from it is that even if you didn't sell the configuration assessment, you still done the work for free. That includes this element.
Yeah. Well, if you get a complaint to say that the Wi-Fi isn't working very well from one of your designs, if it was me or you, the first thing we want to do is figure out why it's not working, because neither of us would want to have one of our designs to be spoken of like that.
It takes all the satisfaction out of the project, right?
Yeah, and I took a lot of time with that design, and I knew that it would work great if it was implemented correctly. So I was very keen to have a look at the configuration. And that's one of the best things about these cloud controlled wireless solutions, is it's so easy just to be able to get added to the cloud system, so you can have a poke around. So Meraki and Mist, whereas if it was a traditional installation, you might have to set up a WebEx, you might have to set up some sort of Zoom or get VPN access or some remote box or something, so you can get on and just have a little poke around. Whereas they just go to the organization, add me as a read-only admin for a time being, and I can literally just have a look and give them some advice, and it was win-win for everyone.
Yeah, absolutely the case. I also like the simplicity of just peeking at the config from cloud-based solutions. And also we have recorded, I think, 2 podcasts about the configuration assessment. So what do we look for in the configuration of a Wi-Fi system? So it's also vendor agnostic, so it's just like a bunch of best practices against recommendations and requirements of a Wi-Fi network. So if you go back several podcasts, you will see the configuration assessment part.
And just one more thing that I want to mention it, is that it's really important to check what the client's capabilities are, because I was aware that they were using Radius for authentication for this SSID and doing like EPTLS. I wanted to enable 802.11r, so two of my recommendations was to go from layer 3 configuration on the Meraki for the SSID to layer 2 bridge mode part of the network, so then you could enable 802.11r. But I got the exact make and model from the customer, so I could double check that these devices support 11R, because if I had then recommended, can you go to bridge mode and turn on 11R, but then none of the clients supported the 11R protocol, then they just wouldn't even be able to connect, so then they'd be having an even worse time. So it's important that you understand what your client's capabilities are, and then how they intend to configure the network and what's important to them, because what I always try to advise customers that you want to be as secure as possible, but if roaming is important for you guys and you want to use Radius EPTLS, but you have clients that don't support 802.11r, then Radius and EPTLS is not the best method of authentication for you, because yes, it is the strongest, but you're going to notice a impact when your devices are moving around your office, warehouse, or wherever it is. So
this is exactly the problem that I ran into in my project that I was working on today. The customer has old Cisco network with RF guns in the warehouse, and they are using Leap authentication, and they do not support 802.11r. Well, there are 3 different types of the scanners having the same model number. 2 out of 3 of them, they don't support 802.11r, and they have a mixture of these devices in the network. So what I have proposed, having in mind that it's just the RF guns, that you don't share the PSK with anyone, it's just being set by the IT once, and the password can be long and very difficult to crack offline. That's what I proposed. Guys, forget about the .1x without 802.11r, because the roaming is slow today, and we are just migrating them to a newer network. And if we stick to .1x, the roaming will be slow as well. So you won't see any gains really in performance in the newer network. It's just like a telnet protocol, whatever, like a text-based application. So it doesn't matter that we are switching from 802.11n to AC or AX. What matters is the efficiency of the configuration of a network for what you have in the network. So I know that after we put it in PSK, it will be way, way better for everyone. But
exactly.
You need to understand.
I think I know exactly what customer you're talking about, actually. I think I've done quite a bit of work with them.
Yes, you have.
As well, yeah. But yeah, it's so important to understand what your clients' capabilities are and how they intend to want to configure their network, because their intentions are in the right place, but then that's your job and responsibility as a wireless consultant to be able to guide them and tell them once they understand, what we run around a warehouse scanning all the time, but we want it to be as secure as possible. Well, you've got two options, mate. You either upgrade your scanners so they can support these protocols, or you drop down to a very strong pre-shared key that gets pushed out by a GPO or something, and you stop complaining that it's not roaming very well.
Yes, but also like very strong PSK is not unsecure. So it's normally not.
I'm just saying it's not as secure though.
Well, as EPTLS, definitely not, because it's theoretically offline crackable, but in most cases, it won't be a problem because the scanners in my project, they were using EPLEAP, and I don't think it's where...
EPLEAP?
Yes.
Huh.
It's old school. So I'm not sure if it's like more secure than a strong PSK really, or any benefits added by using this type of authentication other than slowing the network down by giving the clients a very poor roaming performance.
Yeah, I tend to agree. I don't like to overcomplicate things for the sake of it.
Yep, as easy as possible is the way to go for me and Matt, at least. Okay. So let's discuss how do we perform the RF assessment / validation survey. What are the steps that we are normally taking when we are engaged in a project that involves validation survey, Matt? So what do you normally do? Where do you start?
Well, we start with a survey questionnaire that we send out to the customer to gather all the information, find out what their issues are, what devices they're using, how many floors we're covering, what areas we're covering, and then we can paint a bit of a picture in our head with what's going on site, what their issues are, and what devices they're using, and also what they're trying to get from the network, what they're trying to use the wireless network for. And then generally the first thing that I'll do once I'm on site is I'll open up some form of Wi-Fi scanner. For us now, obviously using MacBook Pros, we will use Adrian's Wi-Fi Explorer Pro. I don't know if it's still called that or that Interbituous. I can't pronounce it very well, but I like to have a look at that because there's so much information you can see straight away. Like you said, Mac, earlier in the podcast, the fact that we can see what SSIDs, how many SSIDs, what channels, what frequency, are they dual band, what channel widths are they using, what amendments are they supporting, what authentication are they using, and a whole bunch more that we can just have a really quick look at. Because sometimes what I found when you go to site is that the IT technical contact for the customer is not very technical and sometimes can't even access the wireless LAN controller or the...
About my project from 2 days ago.
No, this is to be fair, this might have happened to me when I've gone to that customer. And like not everyone understands Wi-Fi to the same level as what we do, or they are that comfortable with getting access to them, or there might be like a central managed IT team in the head office and we're going to a branch site and they can't get access to the controller to let us have a poke around the configuration and see how everything's configured. But by just using a Wi-Fi scanner, we can see so much of the information. And then once I've had a look at the Wi-Fi scanner, what I would tend to do is have a walk around with Ekahau, my iPad and my Sidekick, and do a survey of the environment.
Like a proper survey, very detailed. So when we are doing RF assessment, we really want to identify all the black holes in coverage. We want to go everywhere to understand how network operates physically. So
yes,
yeah, always make sure that what you do is credible. So don't click where you are not walking. It's quite important because you can present back the report to the customer, and then you can see that you are walking through the walls, or you are going through a hole in the floor, or going through the fountain in the middle of a ground floor. And then when you say this is where I walked, and the client says, oh, can you walk on water? Really? Oh, sorry, man, I clicked wrong. And then the customer will say, where else
did you click wrong? Yeah. There's probably 3 things that, as a tip, that we didn't mention that we always do, but it's just that we must have just forgot to mention it because it's just like second nature to us, is that validate that the floor plans are accurate. So we would tend to have an initial walk around with the customer so they can just show us around site, let us get a bit familiar with how the layout is, where everything is, show us around, so then people can also see us with the customer so they understand who these Ghostbusters are that are going around doing some weird stuff with all things sticking out from them. And then the second thing that we would tend to do is freeze any RRM. So log on to a Cisco controller, Meraki, Aruba, Mist, and then do not allow the controller to make changes to the access points whilst you're doing your survey. Because by default on Cisco, the RRM changes, the algorithm can make a decision every 10 minutes. So you go do a survey as you're walking around, you leave one area, you walk into another area, you come back, and 10 minutes later it's on a different channel, different power level, and now your whole survey looks completely different to what it did 10 minutes ago.
You will have access points, right? So you'll have one AP operating on like 3 different channels, and then you'll head what happened.
Yeah, I have seen that as well. So yeah, just freeze RRM. That's a big tip, because the goalposts will be always moving otherwise for you guys.
Yeah, and also that's a very important tip that I often forget to do, and then I really regret that and have to redo the survey. So it's probably better to remember this tip. And the second tip is to do a passive survey versus active survey with survey software, at least. Because Wi-Fi operates, it's Wi-Fi. So when you want to use, I don't know, like a ping test when you're walking around the site, we have to understand that, that ping is like a frequent packet that goes there and back. And every time you send a ping, you have to play the Wi-Fi game, the DCF, using clear channel assessment and stuff, and then have the nav timers, and then you have all the backoff timers and diffs and sifs and stuff. It takes time. And every packet that you send has to compete for the airtime. It has to compete to get to transfer. And ping is, not very high on the priority list of Wi-Fi. So it's normal that you won't see a ping of 1 millisecond every time. Sometimes you will see 2 milliseconds. Sometimes you will see 200 milliseconds. And it's absolutely fine and normal. But it will raise questions from a client side asking, why is my ping so inconsistent? Do I have problems with ping, with jitter? Is my voice going to work? And the answer is, I don't know. Ping won't tell me. If the network is configured correctly, then your voice will have higher probability of accessing the medium, and therefore voice might work while ping might look dreadful. So that's one thing about the ping and RTT. Another thing is about the throughput tests that some clients, they are very passionate about. They just want to run speed tests everywhere. And the thing is, if you come over to the office and you associate to the first access point on your route, and then you go to the other side of the floor with your laptop opened, and you are still associated to the AP 50 meters away because your RSSI or SNR or whatever your Green Diamond algorithm is using, so wherever your device has decided to use to make a decision which AP to associate to, you might be associated to the AP that is not above your head. It might be far away from you, and your device will still consider it a good access point to be associated to. And therefore, the test might be biased a little bit, because if you close and open a laptop, your throughput test will be amazing because you are associated to the close AP. But if you are associated to the wrong AP, well, not wrong, but the AP that is farther away from you, it might be disappointing. So you might have a marketing slides showing you that your network can do 10 gigs. But in reality, you won't be able to get more than, 30 or 40 megs. Is it wrong? Is it not enough? In most cases, it is enough, right?
So, Mac, what do you do if a customer does say to you, I want some throughput tests done on my with my survey? What would you do? How would you recommend that you give them this data?
Yeah, so normally I would recommend not to do it at all, because it doesn't give us any good value, right? If the network is designed for voice and video, I would go on a voice on a video call on a mobile phone, a corporate one, and then walk around the office and see if it works. If it works everywhere, that's great. The network is fit for purpose and it works. But if I really have to do a throughput test, then I will make sure that I have an ePerf or iPerf or whatever perf, a WLAN PI, sitting locally on the network, connected to the same switch, ideally, as the access point is connected to, and I will make sure that I'm associated to the right access point that is close to me to give me good results. So I am testing the capabilities of the access point of the Wi-Fi network, and not the capabilities of a broadband, let's say with a speed test, or of a firewall that gets me to the internet. I want to keep it local, right?
So you would switch off your Wi-Fi, switch it back on, maybe do a stop and go in one area?
I think I will just make sure that I'm associated to the access point that I want to be associated to, that I understand what this access point...
How do you know if you're associated to that access point?
I will check in Ekahau, or I will check in Wi-Fi Explorer Pro, or if I'm a Windows user, I will check in WinFi from Hellgate.
But what if the AP name isn't configured and it's just a MAC address?
Well, I also don't care about... Well, it's nice to see the name of the access point that matches the label on the AP. But if I don't, then I will take a look at, the RSSI levels from the access points, adjacent ones. So I will know that I'm associated to the AP that is best for me. I will also check how many stations are associated to this AP. I will check what is the channel utilization, what is the spectrum utilization. So what I mean by that is what is the spectrum utilization based on the spectrum analyzer duty cycle, let's say in Ekahau, and then I will take a look at how busy the access point thinks it is. It's based on not only spectrum utilization, but also on DCF, CCA, Wi-Fi, the game of Wi-Fi. So even the spectrum might be clean-ish, but the access point still cannot access the medium because of it's being used by, I don't know, like a light management traffic by different access points, overlapping access points, whatever.
But what if the access point above your head has its radio disabled because of some flexible radio assignment, and actually you're configured to the AP that's round the corner because that's got its power level turned up?
Well, I'll probably pick that up, right? I think. I don't know. It's difficult to say. So if you don't have full understanding, it might happen, right?
Yeah, I'm just trying to play devil's advocate here. Be awkward.
Yeah, surprising. I don't have answer for that. Then you'd
have to log on to the wireless LAN controller or dashboard or whatever and check the clients, and then check that your MAC address is connected to that access point.
Yeah, it also doesn't make sense to do a good throughput test in the middle of a busy day in the office, because you won't be able to...
What is that?
What is what?
A busy day in the office?
Well, not anymore.
That doesn't exist anymore, Mac.
Well, actually, you would be surprised. Last week or 2 weeks ago, I was on site with 40% of capacity, and it was still such a heavy traffic there that the access points, most of them, they were on 20, 30, 70% of channel utilization reported by the access point, all of them throughout the entire site, 100-something access points, and all of them heavily utilized.
And that is a very sexy thing that you just mentioned that we also look out for whilst doing an assessment, isn't it?
Mm-hmm. Well, the channel utilization.
Yes.
Well, but this is the part of the Wi-Fi scan, right? Mm-hmm. Because Wi-Fi scan, Wi-Fi Explorer Pro, or any other similar tool, but Explorer Pro is the best, right? Any other tool, you can see the BSS information from the beacons sent by the access points, where you will see how many stations are associated to the access point, what is the channel utilization from the access point perspective, and this is very useful things.
And this is what happened to me the other day. I had one of the Natilic PMs call me up. He was like, I've just changed my home broadband to Virgin. Can you help me with the configuration? I'm in my upstairs office and the Wi-Fi is rubbish. So me, the nice Wi-Fi consultant that I am, was like, of course, let me jump on a Teams call with you and review your setup at home and see if I can help you.
How much was it? How much was your consultancy services?
Not enough. And what this PM had recently done is he'd upgraded to Virgin Media fiber broadband, so he got a nice new Virgin Media box, but he knows that the signal from where he is really, really bad in his office, so he bought some TP-Link extender. So I asked him to log on to the Virgin Media box so I could have a look at the config, but I also said, can you download Hellkex WinFi so I can have a look at your wireless and what's going on in your environment. So he was having a look at the config it was all the default settings. So we went through and cleaned that up a little bit, just disabled the legacy BG, blah, blah, blah. And the channel widths, I want to set them nicely to...
So what does BG stand for, Matt?
BG? 802.11b and 802.11g.
Okay.
On 2.4. So we made it N and AC only on 2.4N, and then 5N and AC. And then I had a look at his Wi-Fi, and what I could see is that the 5 gigahertz clearly was not penetrating through his walls as well as the 2.4. So the RSSI from the 2.4 was about 10 or 12 dB greater than the 5 gigahertz. But the channel utilization on 2.4, because it was so saturated from the TP-Link's connection, using it for the wireless mesh, and there were some other devices around, the channel utilization was, without any stations connected, about 40%, whereas the 5 gigahertz was pretty much 1 or 2%, but we're talking that the received signal strength was around neg 77, and that's what we was using for the call. And then he was like, oh, but the signal's better on 2.4. I was like, yeah, but look at the channel utilization. You've got no stations connected to that SSID, and the channel utilization is at 40%. Whereas, yeah, your signal from your 5 gigahertz is less, but your channel utilization is also less. He's like, oh, okay, but let me try the 2.4. I think it'll be better because it's got stronger signal. I was like, all right, fine, go ahead. You swap to the 2.4 now. So he switched over to 2.4, and bearing in mind we were on a WebEx Teams video share screen on the 5 gigahertz at neg 77, and it was still working okay. As soon as he moved on to 2.4, video distorted, audio distorted, choppy, crappy Wi-Fi, and then 2 minutes later he had rejoined the 5 gigahertz. Okay, I think I'm going to use the 5 gigahertz instead. And that was a nice way for even a non-technical person in a short 5-10 minute process could understand the importance of how having a cleaner channel. Oh, the other thing as well, on the 2.4 there's 2 access points nearby, and on the 2.4 one was on channel 3 at 40 and one was on channel 7 at 40. So the whole 2.4 was just screwed because of the poorly configured Wi-Fi. So that's why it was horrendous. There was channel overlap, it was high, no wonder there was high channel utilization. But yeah, going back to what I was just saying a second ago, the fact that a project manager that's non-technical at all could see in 5 minutes the importance of having nice clean air compared to a slightly stronger signal, it makes such a difference.
True, it does. So in the project manager situation, probably I would install a second access point closer to his room, right? Or in his room preferably.
Yeah, that's what I recommended, but he has an issue because it's all like brick walls and he can't run a cable easily. So then the only other option would be the the pass through the electrics, but then you don't know if it's on the same circuit and stuff. So and that's not that reliable either. So yeah, he needs to run a cable really, but
yeah, that's another thing, important thing. When you buy a house or when you renovate a house, think about cabling infrastructure. So, think about your Wi-Fi and all the other things as well. Because I haven't done that. I didn't have a chance to do it. I bought a new house and I didn't have any structural cabling. And then I ended up lifting floors and moving some stuff around. So I could install 2 access points where I really wanted to install them in. And that was expensive and messy. So when you have a chance, think about it beforehand. It makes sense to have more access points in your house if it's like a bigger house at least.
So Mac, what do we include in the Ekahau template that we give to our customers?
Okay, quite a lot of things actually. But since we've started working in Wi-Fi, our first versions of the reports that we use in Ekahau, they included absolutely everything. So every heat map that Ekahau produces, it was in the report. There's tons of wording around it, tons of explanations. And then our reports for buildings that were 2 or 3 floors, we had 150 pages reports that no one would ever read, I guess. So every new version, we are skimming it down a little bit so it's more digestible for the customers without losing any value. So that's the aim. And now our report templates, they are slightly smaller. So we are including just half, roughly, of the things available in Ekahau. from Heatmap's perspective. So Ekahau captures tons of data, and it can give us tons of different heat maps and visualizations, but depending on the project, most of them won't be relevant to us, or some of them won't be relevant to us. So there is no point including a heat map that requires a measured attributes like spectrum utilization or channel utilization or spread between the access points like associated AP in, let's say, a predictive survey, because the software will try to predict your association to the AP, but of course it will never be accurate. It only, it's only relevant when you go to the site and measure this data, when you are associated to the real access points, and then you want to see what access points you were associated to, then it makes sense to put it into report, but in a predictive survey you wouldn't. Same with the RF assessment. So let's just quickly go through what we include in our template. So our template, actually, what it makes sense to share a screen because this is a video cast. So I will do just that. So starting to share my screen. There we go. Ekahau template. So let me know, Matt, when the screen is shared.
Got it.
Okay, amazing, perfect. So this is a sanitized template that we use for our work. That's the RF assessment version 2 template, as you can see on the top, and the structure on the left-hand side. It shows us how this document is built. So we have some stuff that is generic, which means that it's the same for 2.4, the same for 5. It's not band. It's not related to any bands, and we have some things that can be either 5 or 2.4 gigahertz. So if you, let's say, don't require 2.4, you would delete the entire section instead of just trying to get rid of it. It's
not as simple as that on a Mac as it was on a Windows. You could just right click on that 2.4 and then delete before, but now you have to just go through and copy and highlight it all and then delete it.
Yep. Unfortunately, so previous like in Windows, just click and delete, and here we don't have that beautiful option, unfortunately. But this is what we include in our design. First, in the document, sorry, not the design. So we have a methodology, what we are using, what software, and that we have a Sidekick that we are using. Like it was WinFi. This is like an older report. Now it would be like the Explorer Pro, Wi-Fi Explorer Pro. That we have a laser measurement tool. It's a passive survey, and like a easy to understand statement of what we are delivering to a client. We are using tags from Ekahau in Ekahau, like a JSON notation, using tags available on Ekahau website. We won't dive into how to create a custom report here, but you can create a very powerful custom reports that take only the stuff that is relevant to you and your customer directly from Ekahau into the document that looks like your document, with your branding, with your tables, your colors. It looks amazingly professional, and you can smash the documentation in a fraction of a time that you would have required if you didn't have these templates. Right, Matt? It's like normally it was tons of copying and pasting to make your document look branded. And
screenshotting heat maps and then pasting them in. Yeah. So we don't do pretty much any of that. There is one more improvement in our templates that I can see now with the starring the location in RTFM. How do you call it? Like putting bookmarking. Yeah, there we go. So we will add that to the report shortly. But that's what we have. So we have flow names, flow loops. It's too small for you to see, but that's where it starts. And we have some visualizations of requirements and areas. I will show you in a sec how it looks like in a completed document, because I've run this template against the document. And we have good looking, our colors tables that capture the coverage areas, coverage criteria. So what is the required SNR, secondary signal strength, primary signal strength, and this kind of stuff. What devices we are expecting to have on site. It all captures this information directly from Ekahau. And then we'll have like a visualization of the access points,
where the access points were located when we were on site. We've performed the passive survey, so we were walking around the site and scanning everything around us, and then Ekahau positions the access points where it thinks they are. We will see that on a map. And then we have a table, looped table, so each access point will have the access point name, vendor, AP number. If you captured the image in Ekahau software with your iPad or with your computer, doesn't matter. It will get this image. It will make it lower resolution, just 70 millimeters high, and it will also include AP nodes. So if you captured some AP nodes on site, like this access point, was here and there, and it should have been mounted differently, you can have these nodes in the table as well. We show survey routes. It's nice for the customer to see which areas we have visited and which areas we skipped for some reason. It will show the customer where you were, how much time it took, what was the distance that you've covered, and this kind of stuff.
I think this is quite an important element that a lot of maybe other Wi-Fi engineers do not include in their reports. But why I think this is so good to include is because this means that the customer can see where you have walked, your duration, and how much time you were there. But more importantly is the fact that sometimes if you looked at one of your heat maps and there was like a big white gap, they might just think, oh my god, I've got a huge coverage hole. But then you can go back and check the survey path and just realize, oh, actually we couldn't get access to this part, or this was not in scope, and that's why there's no heat map on this area of the floor plan. But yeah, this definitely is something I would recommend that any of you wireless guys that are listening or watching start to include in your reports, because it's vital for showing where you've been and where you haven't been, so then the customer can understand why they're not seeing heat maps.
Absolutely. Very important stuff. And also we have associated APs. So here we have to be careful because by default, associated APs, even if you've done a passive survey, so you walked around, Ekahau will by default show you the predicted associated APs instead of measured. So here I specify that I want to see association mode measured, and you can also change that in options in Ekahau. So when you go to associated APs heat map in Ekahau, in option, you can change from predicted to measured. Very important, because predicted doesn't give us any value, and measured is amazing because you can see the roaming trends, which APs you were associated with, and where do you have 10 access points, but you are associated to just one. Doesn't matter where you go around the site, it will be just one access point. It will display that in a colored way, easy to see and spot any hogginess, like when the clients they stick to the AP and don't want to let go. Important. Then we show the capacity health. What we show here is we've specified where the clients are with coverage areas and how many of these clients should be able to use the network there. It's not perfect, it will never be perfect. You won't be able to model capacity usage perfectly at any point. It's just not possible. But if you specify that this area should serve 100 connections at the same time, I've missed the word. How do you say it, man? Consecutive connections at the same time.
Yeah, 100 consecutive connections. Or
yes.
Concurrent, yeah.
Current connections. Then the capacity health will show us if it's passed or failed. And if it's failed, then why? Airtime or whatever. We have data rates, so when you are on site and you walk around, it will be the real measured data rate, raw measurements of the data rates in the areas that you visited on site. So you will see one place had 400 megs while the other area had just 60 megs. Why? Is the SNR low? Is the noise high? Is it a different AP like 802.11n versus AC in a different area, different channel widths? You can see that even by looking at the data rate. Throughput will only include if we are using iPerf or ePerf or something like that we've discussed. And round trip time, normally we wouldn't do it. This is a very rare occasion where we would do that. So normally I would just remove that from the report. We show coverage per access point in nice 3 columns, so it's not too big in the report, but it's big enough. You can zoom in. It's like a higher resolution picture, so you will still see what's happening there. The purpose of it is to see, just by glancing at one page or 2 pages, you will see what access points cover. Is it entire building? Is it just part of the building? How the signal propagates? So it's not like super detailed, but it gives you an understanding of how your access points cover stuff. And now we are getting into the band related heat maps and visualizations. So we have the same set of things for both 2.4 and 5 gigahertz. So let's just cover 5 gigahertz. So first was the coverage per AP. Then we capture primary signal strength, secondary signal strength. We don't capture, as you can see here, like AP redundancy or stuff that Ekahau offers, because if you have primary signal strength and secondary signal strength as well, you don't care how many access points you hear from any location with an RSSI of higher than X value. You don't care about that because you know that primary signal strength is fine. If that fails, you have secondary signal strength. You don't care where it's coming from, but it's there for you. So you have AP redundancy covered. Roaming will be beautiful. If you have both primary and secondary signal strengths, nicely covering your building. We capture interference, noise. We capture the S and R signal to noise ratio, extremely important thing. We normally design to a specific SNR value, like SNR of 25, let's say. Then you do post-deployment survey. If it's 25 plus everywhere, that's fine. If it's less, what it means that the modulation scheme that your device is using will be lower than ideal. So you would like all the devices to use, let's say, at least QAM64. So SNR must be at least 25 dBs, roughly. Then we have channel overlap, extremely important thing to include in the report, because this is the main issue, troublemaker in Wi-Fi. The worst enemy of Wi-Fi is other Wi-Fi, and this is normally being seen as a channel overlap, or hopefully not adjacent channel overlap, which is even worse, or overlapping BSS or BSS, which is even worse. But we do include channel overlap for my access points, so how your own corporate access points contribute to channel overlapping in your own network, and then all access points, so both corporate APs plus APs from your neighbors, adjacent floors, different tenants, public Wi-Fi, hotspots, interferers, ROG APs, all of them, they contribute to channel, cross-channel utilization, channel contention, CCI, many names of the same thing. And finally, we have network health and network issues, and that concludes the Wi-Fi modulated part. So network health will just show us like in green or red if our requirements were met everywhere or not. If not, where they have not been met. And in network issues, these areas that the requirements have not been met will be colored. And Ekahau will show us what was it, what was not met. Was it the primary signal strength, secondary, SNR, or something else? And then very lastly, we have spectrum utilization. This is a raw spectrum utilization duty cycle. So physical utilization of a wireless space on a specific band. So it's not the same as channel utilization specified by the AP, two different things. This is a physical spectrum utilization, and channel utilization is the logical utilization of a channel as access point sees that. That's really it. At the end, we have a summary. So this is all the attributes that we look at in the summary, like signal strength, interference, noise, SNR, rogue devices, channel overlap, capacity health, AP redundancy, roaming, spectrum utilization, sometimes packet loss or RTT, but very infrequently, only in specific cases. We check if the site is affected by DFS or not, extremely important thing. So radar activity, it can affect the choice of the channels that we use in 5 gigahertz. And then we check the models, types of APs and antennas. How are they mounted? Where are they mounted? What are they covering? What they are not covering? Do they cover not enough or too much? We check that as well. And then at the end, we have like a very quick summary section where we just put some words around what was the signal strength like. Signal strength was, amazing across the entire site, or it was bad in meeting room A or B. This kind of stuff. So normally when the exec takes this document into his hands, they will just read the summary section, and we will also have like underneath a recommendations section. And that's really what they care about. They might go and read the exec summary or stuff like that. But I'm sure that they won't be diving into the heat maps necessarily. So now, extremely quickly, let's take a look at the report that we have created using this template. So we won't be talking about what it's there because we've already discussed it. So it will be just like a glance at how it looks like. I'm switching to a second document. So Matt, make sure that it looks all right in the video. That should be the report, like a real report. Okay.
Yep,
so
can see it now.
Yeah, this was like zero touch. We haven't configured, changed, amended anything here. This is as it comes from Ekahau. The only things that we've put in manually was summary and recommendations because, Ekahau cannot help us with that yet.
But Mac, I think it's probably worth mentioning how many hours did it take to build the report?
I think it will be counted in hundreds now.
I guess. So, yeah, I mean, if there's any Natilik customers listening thinking, oh, you can run a report very quickly now, or thinking that, you can get all this information very quickly, we can get these reports back to you faster. It's not the case because there's so much time that's gone into pre-building these reports, and we still do add manual parts to these reports too.
Well, but the reports, they are amazing in getting information out of a software. This is just a raw information, and the value that you add as an engineer is in the summary and recommendations, because based on this beautiful, good-looking report, you will be putting summary and recommendations together that the client will be able to follow to improve their network. Just a raw data from Ekahau, it won't help anyone, right? Until you know what you're doing. Okay. So this is how it looks like. All the tables, they were populated automatically. So I have both floors. I can see what's covered, what is the coverage area on both these floors. I can see the Wi-Fi devices, what are the capacity, how many devices on the floor, what is the coverage criteria for 2.4 and 5. These are separate things now. So in Ekahau, you can specify different requirements for 2.4 and 5 finally, which is an amazing addition to a newer software. I think it was added in 10.2. Coverage area name and stuff, like what were the success criteria you were using. We are using like Ekahau best practices, but it can be multiple different areas with multiple different coverage area requirements. So you can have like an open space like we have here, but you might have like a big room in the left corner, bottom of your plan that is a theater. And then once a week, all of the employees for this massive space will be attending a town hall meeting in a limited space. So it will, of course, have different coverage criteria requirements. So it's possible that in a small area, you'll have this 1,000 devices at the same time, but in a fraction of the area when compared to this open space. Then we can see what access point we've seen on site. So they are on the map. They have some numbers. So you can see number like 35, 36, 37, whatever we have. We have number 1 somewhere. There we go. There is number 1. And then we are looking at the table to the right. We can see what was the access point name, what was the vendor, what was the channel it was on. If it was on channel like 40 megahertz channel, then it would be indicated here by, Ekahau would put it in the report like 140 at 40 megahertz. I can see what SSIDs are broadcasted there. So this is like a very nice view of where the APs are and what do they do. And then the survey routes. This is actually a very nice example here. You can see that the survey route, it looks a little bit erratic. It's like not straight lines. It doesn't look perfect. So what I was using here, I was using a drunken mode. It's like the AR-based iPad survey where it gets the route automatically for me. So I don't have to click where I am. It will estimate where I am. So I just click when I'm in the wrong position when compared to the real position in the map. To correct the position in Ekahau. So this was very useful here in this area because it was open space and the plant didn't have furniture on this open space. So it was very difficult for me to relate to where I was on the plan while doing the survey. I started on the very bottom with just a continuous survey, but I quickly realized that I will not be able to do it nicely and accurately. And hence, I've decided to use the drunken mode for the first time. And I found it extremely useful in environments like this one. So it's not a gimmick. It's not like a flashy thing from Ekahau. It can be very useful. I wouldn't use it in a nicely furnished office with great plans showing all the furniture. But if you don't have reference points, this might be amazing for you, as it was for me. Associated APs, I wasn't associated, so it's empty. And then it will show you what APs I would have been associated. There are no colors here, nothing useful because I wasn't associated with any APs at all. So we just listed them all. And then capacity health based on the requirements. Some failed, some passed. Data rate, pretty consistent. You can see that there is like a lighter green color on the top part. And what it translated into, they were using all their access points in the top part. And then we have some throughput round trip time, probably to be removed, as discussed. Coverage per access point, really nicely showing that, access point in the middle of this massive building, it covers entire building, right? So this is like our wand colored, better than NEC 67 or 67. It's covering everything. And then the gray area, it contributes to CCI everywhere. So every access point, they were omnidirectional mounted like 10 or 15 meters above the ground. They were covering entire building. And that's absolutely not what we would like to see. Primary, secondary signal strengths. So, just by looking at the report, you can see that some places they are just on the edge of the coverage requirement in some meeting rooms. That's where users were reporting poor quality Wi-Fi, actually. So that is nicely visualized for a client. Interference, sometimes it was quite strong-ish, especially on 2.4, and so on. So now we are on the 5 gigs already. We can see that the channel overlap of my access point is pretty much identical to channel overlap of all access points. All access point is overlapping a little bit more, of course, because of 1 or 2 hotspots that I've seen on site, but it was an only building in the area. So these two were similar, actually, but it's quite high. It's exceeding 4 everywhere. It was actually like peaking at 15 or something, and very frequently averaging at 5, 6, 7 in the open space, which is a little bit too much. Network health failed in most of the building, and that's because of the purple here, which translates to channel interference, CCI, channel overlapping, channel contention. And then lastly, spectrum utilization. You can see that it's quite heavily utilized from a spectrum perspective. But as I've also captured, it's not in this document because this was just like a quickly done document. The client documentation, I captured the Wi-Fi scan as well. And the channel utilization there was averaging at like 50, 60, sometimes 70%. It's a lot. And then in the summary, this is what you normally would see in the summary. So what we specified was like, signal strength is very good everywhere except of meeting rooms in D7 area where it's low. Interference, measured noise is generally low, sporadically exceeding NEC 85 dBm, which is standard-ish. Signal to noise ratio is generally high, rarely dropping below 25 dBs. So, we just put a sentence or two about what we have seen on site. So the client, just by reading this short table, can understand what is happening in their network. So they see this is like a yellow, okay, fine. This is green, dark green, yellow again. What is red? What's wrong? Capacity health. So capacity requirements are barely met today with just 40% of predicted future capacity working from the office. And that's bad because try to imagine that coronavirus is gone. Everyone is coming back to the office. Perhaps that won't happen, but let's assume it will. And the Wi-Fi wouldn't work anymore. It would be very slow. So no more voice calls, no more video conversations over Wi-Fi. Roaming was very slow. With current RF design, all APs having built-in directional antennas, every single ceiling 9-10 meters high AP in the 8 covers entire open space. So of course, based on that, we have produced predictive design with more directional antennas, better physical design that will translate to a better Wi-Fi. And then just recommendations extremely quickly. Based on the RF design, and actually it was based on the configuration assessment as well, we can see recommended actions. So follow the new wireless RF design outlined in predictive design section. It's not included here, but we've completed it. Remove rogue APs, reduce number of SSIDs, consider updating code, disable WPA support. Some SSIDs were using that instead of WPA2, which is, WPA is crackable. Enable 802.11r fast transition for the corporate SSID. Make sure it's enabled and not adaptive. Enable 802.11k neighbor list for all SSIDs. It's
why enabled and not adaptive?
Yeah, you can answer that because you haven't spoken in a while.
I just thought you like the sound of your own voice so much. Your configuration assessment here you're referring to is a Cisco configuration, so Cisco WLC and WLAN. So if you choose to make your 802.11r fast transition adaptive rather than enabled, it's only going to work for Apple devices. So if you have Windows laptops connecting to this SSID or Android phones or blah blah blah, they will just not use 802.11r. This is purely for Apple only. I don't know why they don't just change it from adaptive to Apple.
Because that wouldn't be too Cisco then. It will be too easy to understand.
Yeah, so that's why you want to make sure it's turned to enabled, not adaptive, if you've got non-Apple devices connected to the 802.11r SSID.
Yeah, and you can see that we are only recommending enabling 802.11r on just one SSID, which is a corporate SSID with EIP-TLS authentication, because that makes sense. So you don't have to re-authenticate every time you jump between the APs, you roam between the APs. That's why it's there. It doesn't matter. It won't help us if we had like a PSK-based SSID or open or like a guest portal, something like that. It just won't matter in this case because we are not talking to the backend radio server. We don't require the authentication results to be pushed down to the access points as part of the 802.11r fast transition. But on the other hand, we are recommending to enable 802.11k on every SSID. And that's extremely important, right? Because without 802.11k, your client, when it wants to roam, when it decides that, it's time for me to start scanning, it's like, it goes into panic mode, then it will have to still stay on the channel that is being served on, like in the middle of voice conversation, let's say. But every now and then, the client will have to go off channel and scan for a better alternative. It will have to find a better AP on its own. So it will have to scan how many channels, like up to even 38 channels in Europe, 13 on 2.4 and 25 on 5, before it decides which channel to use next after it moves to a different access point. With 802.11k, it's extremely simplified because a client can ask his own access point that is serving this client, Mr. Access Point, what are my best next options? And the AP serving client will just come back to the client with an enable list saying, these are the best alternatives that I can see from my perspective. So it will only send to the client list of APs with the best RSSIs, let's say, being seen from the access point that is serving client at this point. And the client will just scan like, 1 or 2 or 3 or 5 channels instead of 38, let's say. So that's a massive gain. And it's not affected by the authentication method. It's beneficial for every type of wireless LAN, even if it's open. Okay, assuming 2.4 gigahertz is not required, turn off all 2.4 gigahertz radios because we've proven, in the RF assessment validation survey that 2.4 is pretty much dead, overutilized, massively bad channel overlapping. So it makes sense to set everything to 5 gigahertz only if we can. And also disable band select in advanced tab. We don't want our SSIDs to use something called band select, band steering, or being dual band. Long story very short is that if you have dual band SSID, your devices will be way slower to roam. And also in most cases, you won't be able to ensure good quality Wi-Fi on 2.4 gigahertz band. Even if you do your best with configuration and everything, this band is just so nasty in most cases that it just won't work. Okay, and last recommendation was to set maximum power level allowed by a dynamic RRM, it's called in Cisco, to 17 dBm. Okay, because it was allowing 30 dBm, and most of the access points were blasting at maximum allowed power level of 30 dBm, and that's it. So that was the quick. Well, it wasn't too quick, was it?
Not so much, but it's very good though, and I think a lot of people, if they are just listening only, they should definitely come and take a look at the YouTube video of this and have a look at the report, because it's very insightful and then can give them some very good ideas for their own reports.
Yeah, hopefully. So yeah, I hope that people will benefit from the time that we've invested into these reports, like quite a lot, right?
Yeah, the feedback we get from every customer that we send this to blows their mind, doesn't it?
Yeah, so this report was like there was nothing special in there. Normally sometimes we are engaged to do all three types of, assessments and surveys. We do configuration assessment, RF assessment, and based on all that, we produce a predictive design, all part of a single beautiful document.
I actually put a picture of you in my latest report.
Oh, really? Were you presenting to the client a wireless anchor?
No, I just put in there from our API on a stick testing, so I put in the photo from us on site the other day.
So they must have been disappointed that you have a moped wearing pajamas on site.
They haven't seen it yet, I don't think, so I've still got to play that back to them at some point next week, but I thought I'd put it in there, and since the customer knows you well, I thought they would appreciate it.
Yeah, the survey from this week.
Yeah.
Good design. It will be a good design. Another design for a warehouse. I feel like we are doing more design for warehouse these days than enterprise spaces.
Yeah, well, warehouses have got to keep going. The warehouses are probably busier than ever with a lot more people at home and ordering stuff online. The warehouses is what's keeping everything going during the COVID.
Yeah, true. And enterprises, they are not as busy as they used to be.
Yeah.
In central cities.
Mm-hmm.
Okay, so that was the Ekahau templates and quick template demo.
Yep, which I kind of feel like you covered what our typical recommendations are going to be and the typical issues that we come across, right?
Well, I think so. Yeah, we can spend a little bit more time around typical issues because I've just discussed briefly the issues on that particular site. But what are the most problematic issues that you see, Matt, from your perspective?
Quite a lot of the time from doing the assessment, I find that access points or antennas, they're installed incorrectly. So APs are vertical rather than horizontal, they're above a ceiling, or they are not in the positions recommended. We also recently, when we was doing that survey last week, we saw that the access point with the external antennas were meant to be installed with a vertical polarization. They were installed with a horizontal polarization, so they're covering nicely straight up and straight down, but not around like they were meant to be. So we come across installed access points and antennas incorrectly quite often. I say that's probably one of the biggest ones. And also it feels like a lot of Wi-Fi installations, people literally just put it in, get it working and walk away. There's no best practices implemented, because quite a lot of the time I see is Wi-Fi networks with all default settings, so default power level settings, default RRM settings, default algorithms for when you can't make the changes. So we're seeing various different channel whips and not just sticking to one size channel whip, so that's causing like primary, secondary OBSS, lots of channel contention. I see a lot of dual band configured SSIDs where we like to now just try and stick to either one or the other. Go 5 gigahertz only as much as possible for all of your business critical devices, and then any of your maybe like IoT or AV or guest networks, you can make them 2.4 only, or create a carbon copy of an SSID and then include like an underscore legacy. So if you have Wi-Fi Ninjas guest, that would be 5 gigahertz only, and then you could have a Wi-Fi Ninjas underscore guest underscore legacy, and that could be 2.4 gigahertz only.
So Wi-Fi Ninjas guest, it will be 5 gigahertz only. If you have Pubcast guest, it will be 2.4 on channel 7.
Yeah, that's what we would call it. Wireless Pubcast would be 2.4 only, 40 megahertz wide channels, and all basic rates enabled. So it's kind of like the difference between our podcast and their podcast.
Yeah, so we are doing it professionally. They are doing it for fun, right?
Exactly.
I wonder.
I wonder if they still listen to us now. Maybe they're too big time to listen to our podcast anymore. And
it's a Wi-Fi. Just how many of them they create wireless podcast? Like 10 people?
4. No, there's 4 of them.
Ah, okay.
Yeah. You was going to be on it, but that didn't happen, did it?
No. So they invited me, then dropped the invitation. Bad guys.
Yeah, they already had the best Wi-Fi Ninja, so they didn't need the other one. So the poorly configured SSID. So I've mentioned this a lot earlier at the beginning of the podcast, is the authentication and what the client's capabilities are. So the .1x configured SSID, but without the fast roaming amendments enabled. So when the client comes and wants to start roaming and they don't support it, or it's not configured, I see that a lot of the time, and I have to advise customer how to best configure their network for their clients. What else do I see quite a lot? I think low data. Like I said earlier, a lot of networks, it feels someone comes in, they may manage to get it working, and then they just walk away, but they haven't done any best practices. So all just a default setting. So the low data rates, crazy channel whips, crazy power levels.
They're just good for speed tests, right? So that's what vendors, they normally put the settings for. So it's like by default on 80 megahertz everything. Of course, it won't work in enterprise, but in the middle of a night when you finish putting a system together, and then you have someone like, a bills payer coming over to check the performance of the network, they run a speed test, and oh my God, it's fast. If you put it properly on like 20 megahertz in high density, it wouldn't be, too fast, but it will be consistently good quality.
It's just not needed as well. Like, if you look at how much data that I'm just using right now at home, doing a video call with you and recording it, my traffic at the moment, I'm doing less than 400 kilobits up and down. So when customers are like, oh, I need 1 gig Wi-Fi, and you're like, no you don't. A 20 megahertz wide channel with an AC client.
They needed like dual multi-gig ports in their access points.
True.
It's okay. It's just AP, new switches, twice as many.
Yeah, like we're basically, this is a HD video live call that we're doing, and it's doing 363 up and 350 down at the moment. So
same, consistently throughout the call, pretty much.
Yeah, so it's just that people, when I say, I need these crazy speeds, and like, mate, no you don't. No, you do not. The other thing that I really don't like is with the default setting, especially on Cisco, is how often they'll run through the algorithms to change the channels and change the power levels. So by default, it's every 10 minutes. So every 10 minutes, your wireless network can be changing, which I think is far, far too often. If you're on a voice call and then the access point goes, you know what, this channel's got a higher utilization than what it did 10 minutes ago, I'm going to change the channel. Then you in that voice call, video call, you're going to notice that channel change happen. And the reason why the channel is more saturated is because you're on the voice call. So having a network that constantly changes its settings, I don't think is great. I always set it to happen once a day, so every 24 hours, or at max every 12 hours. So it's not going to be client impacting. Set it outside of usual office hours or business hours, but then turn on things like event-driven RRM. So if someone does come in with some sort of interference device on that channel, or that channel does get crazy saturated, then it can make a decision, go, you know what, this channel's crap in the bed, let me move to another one, rather than it just constantly doing it.
Yeah, and that's an extremely important thing, because what happens when the access point changes channel, it just sends a quick notification to clients, guys, I'm changing channel, and then
bye. Get off.
Yeah, most of them, they won't even know what to do with this notification.
Panic.
They will just push the bed and get disconnected gracefully.
Can't say that.
Let's hope that
no you
heard it. Well, okay. From my perspective, what I can see is mostly the CCI, so channel interference, same channel interference. That's the biggest killer of Wi-Fi performance in pretty much all the verticals that I visit. Sometimes it's not unusual to see like even 30 plus access points operating on the same channel, which means that all the clients associated to this 30 plus APs that can be heard with roughly neg 85 or higher RSSI, they will be contending for the same airtime, and only one client associated to all these 30 APs will be allowed to talk at any given time. There will be tons of collisions, tons of retransmissions, and it will be just dead slow, right? So that's the biggest impactful thing from my experience. And what is it caused by? Normally, it's caused by just neighboring networks, wrong configuration of the channel widths. Sometimes, you have this crazy, as you mentioned, like everything on default on auto with dual 5 gigs, 80 megahertz channels that are just bad, extremely, for everyone around, including yourself. So that's the number one thing. But in more challenging environments like warehouses, manufacturing, people, they just tend to be scared of external antennas, I've noticed. So very frequently, I go to the warehouse or like a harsh environment with tons of metal, very extremely high ceiling, and I can see, Omnis installed every 10 meters at 20 meters high. And each and every access point covers entire space with not too good RSSI because it takes, 20 meters until it even reaches the ground, which is bad in its own. And the CCI will be really bad there as well, normally, if you have tons of these access points. So, these environments, they are perfectly suitable to be used with external antennas. So you cover only what you want to cover, and you don't cover what you don't want to cover. And it's also as important as covering what you want to cover, because if you cover what you don't want to cover, that's where you have covered too much and suffer from extensive CCI. So types of antennas extremely important. Anything else that we haven't covered and we see very often?
I think we've covered.
We mentioned DFS in here. It's also happening quite frequently. So sometimes Wi-Fi systems, they don't have intelligence or they're not configured to use dynamic channel assignment, let's say. So they can be massively affected by DFS. Can be false positive, can be the real thing, but access points, they think that they are massively affected by DFS. And if these APs are configured to use DFS channels, they might keep on trying to use DFS channels. And what happens then is very similar to what happens when the RRM change of channel. It just, the access point says, oh, wow, I've been hit by the DFS event. I will let my clients know. And then, quick notification change to the clients. Guys, bye. You have 100 milliseconds to pick a better channel. And some clients will know what to do with that. Most clients won't, and they will just be disconnected. So DFS is also, especially around the airports, can be heavily impacting thing. I had DFS issues with my own network back when I was living close to Heathrow Airport.
So I think that's probably it.
I think that's probably it.
Cool. Okay. Well, thank you very much, Mac, for your time today on the podcast. I hope that our listeners found this useful, because I know if I had just started out in Wi-Fi, I was working Wi-Fi for very long, all of this information would be something that I would like to start including in my assessment. So if you guys have enjoyed it and you have any other questions you want to ask us, feel free to reach out to us and we will help you if we can.
Yeah, anytime. And I also think I can hear like banging the door. Time for me to go. But I think that there will be a course available, like one day course that will be talking only about the assessment templates.
Oh, yeah.
Useful.
Customer reports.
Yeah.
Nice.
So that's amazing as well.
Cool.
Okay. So thank you very much, Matt. Thanks, guys. And if you have any questions, feel free to reach out.
Yeah. Cheers, guys. Thanks, Mac. Bye.
Thanks. Bye-bye.